Now we've done this before with whole numbers. Now suppose we have, let me do this, x to the 2 times x to the 3. That's equal to, for multiplication of two numbers with the exact same base, all you have to do is add the exponents, keep the same base, so that would be x to the 5th. In the exact same way, if we have rational or fractional exponents, positive or negative, it doesn't matter, use the exact same rules. The base is the same. So therefore, you have x to the 3/4 plus 5/4. The base remains the same. We add the exponents, and that's equal to x to the 3/4 plus 5/4. When you add fractions, you need a common denominator, and 5 plus 3 is 8. 8 over 4. 4 goes 2 times into 8, and that is x squared. So what's the rule? When the bases are same and you're multiplying two exponential terms with the same base, all you have to do is write down the base, add the exponents. Same thing here. The base is exactly the same. Both are y's. We are multiplying the two numbers. Keep the base, add the exponents. You can use your calculator. Here the common denominator is 4. So we multiply the numerator and denominator with 2, and we add it to 1/4. So that's equal to y to the 2 over 4 plus 1 over 4 is equal to y to the common denominator 4, 2 plus 1, 3. So it's y to the power of 3/4. Next, division. If you remember earlier, if you had x to the 7th over x to the 3rd, you're dividing two terms with the exact same base. They're in the exponential form. So write down the same base to the, for division, we subtract the exponent of the denominator from the exponent of the numerator. So exponent of the numerator minus the exponent of the denominator. So we have x to the 4th power. For division of two numbers with the exact same base, we subtract the exponent. So now let's see how this works. We have the exact same base. The base is x, and what we're doing is division. So write down the base, write down the exponent of the numerator, subtract the exponent of the denominator. So this is equal to, the denominator is the same, so we can add it right away, and this is equal to x to the -3 over 7. Now usually we don't write terms with negative exponents, so we're going to move that term down. What changes is not the base. We're going to leave 1 in the numerator, is x to the, just change the sign of the exponent. So if it is -3/7, it becomes +3/7. Same thing here. The base is the same. Notice the base is the same. We're doing division. Division goes with subtraction of exponents. Write down the base, go in this exact same order. The base of the numerator minus the base of the denominator. And this is equal to, common denominator is 8 times 7, 7 times 8, 7 8s are 56, 7 7s are 49, minus 8 8s are 64. So that is 64 minus 49. Use your calculators, you don't have to do all this. So that is equal to x to the 15 over 56. If you remember finding the LCM, here in this problem we were finding the LCM of 8, 7. If you remember the prime factorization method, 8 is 2 cubed, 7 is 7 to the 1. Pick the largest 2 times pick the largest 7. 7 times 8 is 56. And that's how we multiplied the fraction 7/8 with 7 in the numerator and denominator. And here we did 8 in the numerator and denominator and did the work. A quick review again. If the bases are the same and we are dividing, all we have to do is x to the exponent of the numerator minus, go in the exact same order, you cannot change the order, the LCM of 3, 6, 3 to the 1 and 2 to the 1 times 3 to the 1 is, pick the largest 2, pick the largest 3, it's equal to 6. So we have x to the 5 over 6, we leave the 6 alone because the 6 is the LCM, the common denominator, but the 3 can be made into a 6 by going 3 times 2. So this is equal to x to the 5/6 minus minus 4/6, and that is equal to x to the 5 minus 4 is 1 over the common denominator of 6. Now, if we multiply two numbers with the exact same base, what do we get here? We add the exponents. Addition can be done in any order, unlike subtraction, where you have to follow an order. So we have 6 as the common denominator, plus 2 times 2 over 3 times 2. We've multiplied the numerator and denominator by 2. So it's x to the 5/6 plus 4/6. This is equal to x to the 5 plus 4 is 9/6. We can simplify the exponents because 9 is 3 times 3 over 3 times 2. We cancel the common factors and we get x to the 3/2. So this is multiplication and division. A to the m, if you remember, let's do an example. A to the 2 times a to the 3 is a to the 2 plus 3. But if I said a to the 2 whole to the 3, then that would be a to the 2 times 3. The only time we multiply exponents is in this sort of a situation. So that would be a to the 6. Now let's look at this problem. A to the 3/4 whole to the 4/3 is a to the 3/4 times 4/3. We cancel common factors and we are left with a 1. So that is a to the 1, which is just a. Now let's look at the next one. A to the 2/3 times a to the 3/4 is a to the, this is the only time we multiply exponents, 2/3 times 3/4. We cancel common factors first. So we have a to the 2 over 4 is 2 times 2. You can always use your calculator to simplify this, and this would equal 2 over 2 is a 1, and that's equal to a to the 1/2. Now we're going to use this rule. Suppose we have a b to the 3rd and a is multiplied to b, then it's just a to the third, b to the third. If we have a squared b cubed to the second power, it would be a squared to the second power times b cubed to the second power. So this is what we've done before with whole numbers. So that would be a to the 2 times 2, which is 4, b to the 3 times 2, which is equal to 6. So this is the rule that we're going to use, except that now we are working with rational exponents, which means fractional exponents and not whole numbers. So the x, y, and z are multiplied together. So we have only if they're multiplied together, this rule applies, or divided, not for addition and subtraction. Each of these terms is raised to the 3/5 times y to the 5/6 whole to the 3/5 times z to the 1/3 whole to the 3/5. So this is equal to x to the 3/5 times 3/5 times y to the 5/6 times 3/5 times z to the 1/3 times 3/5. Now simplify this expression. You're multiplying these two, so that becomes x to the 9/25. Nothing cancels, but if something cancels, make sure you're canceling it. So we have 5 cancelling with a 5, and 3 goes 2 times into 6, and the 2 is in the denominator. So we have y, 1 in the numerator, over 2 in the denominator. And again, see if something cancels. The 3 and the 3 cancels. So we are left with z to the 1/5. And that's your final answer. Make sure you cancel all the common factors when you multiply the fractions. Next, exact same thing. Each of these is multiplied to the other, and the power is 4/5. So by the rule of exponents, it's x to the 3/4 whole to the 4/5 times y to the 1/8 whole to the 4/5 times z to the 5/6 whole to the 4/5. Now we cancel common factors, if any, because we're going to multiply the exponents, because it's going to be x to the 3/4 times 4/5 times y to the 1/8 times 4/5 times z to the 5/6 times 4/5. This is equal to, cancel common factors, x to the 3/5 times y to the 4 goes 2 times into 8, so we're cancelling common factors. It's 1 over the 2 and the 5 multiplied together makes it a 10, and times, we cancel common factors, the 5 and the 5, 2 goes 2 times into 4, 2 goes 3 times into 6, and we get z to the 2/3.